Hello, this is Professor Urbis White. We are going to look at arithmetic sequences. Usually you study these at the end of your college algebra class. So what I'm going to cover is first kind of look at what a sequence is and how do I write it, how do I show it. What is a formula for the nth term, a general formula for a sequence, recursion formulas, and finding a term given, like let's say I have certain logic and I have a series of numbers and I want to know what is the 99th number is going to be. Okay, so that's what we are going to do. So let's get started. Let's look at what a sequence is first of all. All right. A sequence may be a list of numbers, and they are shown usually in side braces. Let's say 1, comma, 2, comma, 3, comma, and usually there's a logical relationship between the terms, and then you're going to have a biggest term and you stop, and we show that as n. And that's called a finite sequence. It just stops. But if you have a sequence that doesn't stop, it goes to n and keeps going, and this is how you show it. You just put dot, dot, dot. That's an infinite sequence. Okay? Examples of sequences. You can show the sequences in braces, or you can show them as typically with an an, that means it's a general term, and give a formula for it. -1 to the nth power and -1 factorial. Okay, and then they may give you that example, and then they may say, can you tell me what A1 is, what A2 is, what A3 is? All you have to do is just put 1 for n. So let's go. -1 to the first power, 0 factorial. What is that? That is going to be simply -1. 0 factorial is 1. A2 is -1 to the second power divided by 1 factorial. 1 factorial is simply 1 as well. So that's going to give you 1. How about A3? That's going to be -1 to the third power divided by n minus 1. So 3 minus 1, that's 2 factorial. And that's going to give you -1/2. So I went ahead and I showed that -1, 1, and -1/2 are the first three terms of that sequence. Now let's kind of review factorial, because it's going to keep on popping up. Factorial means 0 factorial is by definition is 1. 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So know what a factorial is, and we go from there. Now another type of problem might be they may give you a list of numbers rather than giving the formula, and they may say, what is the formula? So they may say, what is the formula if you have a sequence and it goes something like this, 6, 8, 10, 12, and stops. Okay, what you should do, you should actually make a little table and say n. The first term, n is like the subscript tell you which term it is. First term is 6. Second term is 8. Third term is 10. And fourth term is 12. Then you have to look at what is the relationship between n and a of n. And if you look at this, for example, 6, I kind of see it's all even. 2 times 1 plus 4 will give me 6. And this is going to be 2 times 2 plus 4. Here is a trend, 2 times 3 plus 4. What does that mean? an is going to be, I take the 2, multiply by the index, and add 4. and here's a general for it. It takes some thinking, but you can come up with it. You can try different things. But sometimes it's kind of harder when you have alternating signs, for example, in a sequence. Let's look at that. Let's say I have a sequence like this. 1, negative 1/4, positive 1/9, negative 1/16, and so forth. Again, like before, I'm looking for an, and I'm making a table. And when it's 1, 2, 3, 4, I just simply write this. 1, negative 1/4, positive 1/9, negative 1/16, and let's try to find out how this alternates. When it is odd, it's positive. When it's even, it's negative. So I can write this as negative 1 and plus 1, okay? Because that will make it even, and then I'll get a positive answer. Okay, how about this? I have 1 and then 4. 4 is the square of 2. 9 is the square of 3. Oh, I got it. That is actually 1 over n squared. And I came up with the general term. Okay, what else am I going to cover? Recursion formula. What does that mean? Recursion formula, instead of giving an as a function of n, you give an as a function of the previous one. So, for example, an example of that will be if I am given an, instead of giving a function of n, I go, okay, well, an is going to be the previous guy squared minus 5. Can you show me a couple of these, starting with 2, for example? Okay. All right, I can just go and let's say I want the first thing to be, let's say, 3. Okay, so starting at 2, what is that going to be? It's going to be the previous one, which happens to be 3. Square it, subtract 5. I got 4. Okay, well, let's go do this one. That means I'm going to square 4, subtract 5. That will give me 11. How about the next one? I'm going to square 11 and then subtract 5, and that will give me 116. Recursion formulas, you're just writing your formula based on the previous term. Okay, now we looked at the sequences in general. So what am I going to look at now? I'm going to look at arithmetic sequences. What is an arithmetic sequence? That's a sequence of numbers, such as like this. A1 is 2, A2 is 4, and the relationship is obtained by adding or subtracting a constant thing, and that thing is called a D. In this case, it's 2. Because I add 2 to 2, I get 4. I add 2 to 4, I get 6. Okay, so in other words, I have this situation. A1 is A1. A2 is obtained by adding D to the A1. A3 is obtained by adding D to the A2, and A2 happens to be A1 plus D, so that gives me A1 plus 2D. A4 is going to be the previous one plus D, and the previous one is supposed to be A1 plus 2D plus D, and that will give me A1 plus 3D. And I see a trend now. What is the trend? The trend is I always add to A1, but how many times I add it? And minus 1 times, and that is the general term for an arithmetic sequence. Okay, one problem might be they may say, okay, A1 is negative 2, and I want to see, and D is 3. I want to see the first 3 terms. Okay, so they gave me the first term. It is, what is that going to be? The first term is negative 2. What is the next term? it's going to be negative 2 plus, it's going to be, you're going to add a 3 to it. So that's going to be plus 1. What is the next one? It's going to be negative 2 plus 2 times 3. What is that? That's going to be 4. So you have a negative 2, 1, 4. You can see what the next one is. 7 and 10 and so forth. Okay? It's pretty easy. And then you can do the reverse problem. Here it is. Let's say they give me this 2, 6, 18, 54. Your first term is 2. Did I add something to it? Yeah, I added what? I added a D, I added a 4. Okay? So how's that work? I added 4 to it, and then they might say, okay, is this an arithmetic sequence? If it was an arithmetic sequence, I'm supposed to add the same thing each time. I added 4 here, and I'm supposed to add 4 here as well if that's an arithmetic sequence, but I have 18. Therefore, this is not an arithmetic sequence. You can find something else, but it is not an arithmetic sequence. Okay, well, let's look at another one. Can I have negatives? Of course. 5, 2, negative 1, negative 4. What am I doing each time? A1 is 5. And what am I doing? I'm adding negative 3. Yeah, I can add a negative 3. There's nothing wrong with that. Okay, another problem might be, let's say I have A1 and I have A7. Okay? A1 is 30, A7 is 60. They're asking me, what the heck is the D? And if you find the D, what the heck is 13th? Okay, well, let's write the formula for A7 to start with. A7 is supposed to be A1 plus 7 minus 1 times D. What is my A7? 60. What's my A1? 30 plus 60. Does that make sense? So what is that going to give me? That's going to give me D of 5. Okay, now that I have that, I can find my 13th term. A13 is going to be A1 plus 13 minus 1 times D. What is my A1? 30 plus 12 times 5. That will give me 90. Alright, and you can write the general term or whatever. So you can say, okay, how do I write my general term? An is going to be the first one plus n minus 1, 5. Open that up, 30 plus 5n minus 5. What does that give me? 30 minus 5, that's 25 plus 5n. So you can actually play with this whole idea of arithmetic sequence, and it's fairly easy. All you need is the first term and the difference, D. It can be positive or negative.